Hi, this is javinkharod, a chemical engineer by profession, going to continue our today's topic. What are hazards of distillation? Now, what is that? Distillation is a widely used process in laboratory and industries for separating mixture based on differences boiling point. However, it involves several potential hazards that must carefully manage to ensure safety. These hazards include high temperature, vacuum related risk, chemical exposure, and equipment failure. Proper preparation, such ensuring secure connection using appropriate material and monitoring cooling system is critical mitigate the risk. Additional handling high temperature fluid and ensuring adequate sealing can prevent burn, leak and other accidents. Below, explore the hazard. We give the detail and provide actionable insight to minimize the risk. High temperature hazard. Distillation involves high boiling liquid, their boiling point, which can expose operate to high temperature. Hot oil or high temperature fluid can cause several burns if they leak if someone contact with skin. Now, mitigate measure. Use heat resistance material for tubing and connection. Avoid silicone tubing as it is unsuitable for high temperature application. Ensure proper insulation and protective gear when handling heated components. Vacuum related risk. Distillation requires creating a vacuum which can lead to equipment failure or implosion if not properly managed. Improper sealing and insufficient vacuum grease can cause leak, reducing efficiency and increasing the risk. Mitigation measure. Draw down the vacuum to the recommended pressure before starting the process. Apply vacuum grease all the interface, sealing surface and joint to ensure airtight connection. Regular inspect seal and joint for wear of damage. Now, chemical exposure. Distillation involves handling potential hazardous chemical which can cause risk of inhalation, skin contact or ingestion. Volatile compound may release toxic fume if not properly contained. Mitigate measure. Use fume hood and proper ventilation to prevent inhalation harmful vapor. Wear appropriate personal protective equipment such as glove, goggles, lab coats. Ensure all container and connection are securely sealed to prevent leaks. Cooling system failure. Cooling system, chiller, cold trap are essentially condensing vapor during distillation. Insufficient cooling water or low level ethanol and water in chiller can lead overheating and equipment damage. Mitigation measure. Verify the cooling water valve are open and function correctly before starting the process. Check and maintain adequate level cooling liquid, ethanol, water or liquid nitrogen. Monitor cooling system pressure and temperature throughout the distillation process. Now, equipment slippage or misalignment. The distillation flask and other components may slip or become misaligned during operation, especially under vacuum conditions. This can lead to spill breakage or injury. Now, mitigation. Secure all glassware and tubing joint before starting the process. Use clamp or support and stabilize distillation flask and other component. Open rotation carefully after establish vacuum to prevent sudden movement. Fire and explosion risk. Flammable solvent and high temperature fluid can ignite exposed to open flame or spark. Poorly maintained equipment or improper handling of heat sources can increase fire risk. Now, its preventive measure. Use non-flammable heat transfer fluid where possible. Keep flammable material away from the heat source and open flame. Regular inspect and maintain heating equipment to prevent malfunction. Okay. Now, Against maintenance, failure monitor and distillation process or maintain equipment, lead accident or ineffective and inefficient. Overheating, pressure buildup or leak can occur if systems are not regular. Check. Now, is preventive measure. Continuous monitor temperature, pressure, fluid level during the distillation process. Perform routine maintenance all equipment including seal, joint and cooling system. Train operator and proper procedure for emergency response protocol. By understanding and addressing potential hazard, operator can ensure a safer and more efficient distillation process. Proper preparation, use appropriate material and vigilant monitoring, they are key to minimize risk and achieving successful outcome. High temperature hazard, distillation involve heating liquid of their boiling point. They can expose operator higher temperature, vacuum related risk, chemical exposure, cooling system failure, equipment slippage or misalignment, fire and explosion risk. Now, inadequate monitoring maintenance. Some of the biggest hazard life in a distillation column present themselves during initial commission phase or recommissioning after a turnaround. Improper purging of air from tower. During installation, after turnaround, a distillation tower will initially full of air. Air need to remove before introduce hydrocarbon or other flammable. A common way of doing this readily available utility push out air, opening steam to tower base venting from the top. Replace the steam with fuel gas or similar is usually considered to complete when steam can be seen venting from top of the tower. This takes some hour since much of steam initially condenses as result of heating tower wall internal. The primary concern during air freeing is to make sure the tower is not isolated with steam inside because of the potential of the steam to condense and create a vacuum in the tower which it may not design to handle. Now, safety issue identified. Air freeing might take longer with a divided wall if there are reasons to flow of the purge steam preferentially move up one side of wall versus other, or conversely it may possible to think purging complete viewing steam at the tower vent, and when there are still some air on the side of divided wall since where steam flow is restricted. Conventional steam out procedure should consider location, purge steam feed and tower layout. Confined purge is reaching both sides of divided wall. Inadequate cleaning debris from tower. Incident have occur result heavy scale or loose bolt, globe, weld sludge, etc. Initial installation activity they are inadvertently left behind when the tower is closed in the same distillation column method, which was used separate range of hydrocarbon, petroleum, liquefied petroleum gas and heavy gas oil. The tower was eventually air-free. The unit was started and feed mixture sent to tower for separation. Tower and tray were constructed carbon steel. There were some scale present in the system. One bulk hot liquid started flowing through the tower. All the debris, include scale and leftover component such as nut, bolt, etc., was washed to the bottom of tower and bottom of pump. Pump were protected with the suction strainer, but because of huge amount of debris, the strainer then become plugged only second into the operation. In order to clean the strainer, the pump had to be shut down, the strainer isolate and line open, the strainer removed, clean with steam hose, then reinstall, line open, reopen and pumps restarted. This process was difficult enough for operator to keep up the given repeatedly strainer plug, but in addition, the process fluid at the bottom of tower was above auto ignition temperature. there was not enough interval between strainer plugging or adjustment pump to allow the system cool down, removing strainer for cleaning. Now, therefore, the operator were forced to open up strainer pipe segment, deal with the fire, and start a strainer contact and contact it with the air. To manage this previously activity by having people presented near around with the steam lamps to snuff the flame and cool the equipment while someone else cleared debris from the strainer. The activity took hours but was completed without anyone being hurt. It would have been preferable avoid problem first place having someone simply lost down and but they were completed without anyone being hurt. It would have been preferable avoid problem first place having someone simply hose down and debris from tower before tower was closed. Safety issue identified. With dividing bolt tower, there may be more opportunity to lose debris to accumulate undetectable location. Special packing set, high efficiency valve tray may more sensitive to residue debris accumulation from fabrication. All through the application are also presumed to more likely stainless steel and other material of construction that will reduce scale formation. Now liquid filling the tower, fouling. Distillation column performed. Best feedstock is clean, free from particulate. However, this is always the case sometimes. There are scale buildup in the column. There have been cases. The limited scale buildup has not been problem with conventional tower internal standard saddle packing. However, when being replaced with the higher efficiency packing, the scale buildup time does become issue can affect distillation performance. Safety issue identified. While reduced efficiency isolation will not be issue, continued buildup could lead higher pressure drop, potentially unstable column operation. Column pressure relief system are typically located top, so increased bottom pressure may bring condition closer to design limit than for conventional packing. Good operating practice should prevent issue with other pressurizers. There are increased risks associated with isolating, decontamination, and opening up the process equipment for maintenance. So column require more regular shutdown and decontamination for cleaning of packing. This may increase overall operational risk. Flooding. Flooding occurs when upward flow of vapor and downward flow of liquid increase point, which liquid can no longer flow down the column. Such event occur a plant not longer initial commissioning any startup on new plant. It take time a board operator to get a feel from how equipment operate and respond changes in set point. This can be more prevent facility less experienced operator. Even so experienced operator can create flooded tower. A distillation arrangement include overhead condenser, receiver, reflux and bottom recoil. The typical sequence event lead the flooding in distillation column. It follows overhead and bottom product commissioning and composition are off spec for whatever reason. Initial operator instinct, it look like it may need more reflux to generate more liquid traffic, so the operator add more reflux. It quenches the tower, doesn't help bottom product quality, so the next instinct to add more heat to the reboiler. That doesn't help either. We discussed step 2 or 3 are repeated until tower confront from their issue such higher pressure unstable operations. Now, in one particular commissioning case, no progress was being made to resolve the issue. It was decided giving typing to fix the situation and instead to crash the column, stop heat and rebuild the stretch. Fortunately, that was workable options without causing operational issue because commissioning was underway and tower was not yet fully integrated with the rest of the plant. A flooding situation generally is not safety concern except the progress to the point of overpressurizing system, point tower, should be protected by pressure relief valve. Now, safety issue identified in divided wall column. There may be more tendency to inadvertently create a flooded condition on one side of wall in order to optimize performance other side of the wall. Add complexity may require greater degree of knowledge and understanding the operator how bring column back to column stable operation. Concentration buildup. Some of the distillation operation, particularly non-ideal solution, are involved, lead to how higher boiling azeotrope mixture can result concentration of particular component, certain tray and level column. This could lead problem material construction. In this case, certain compound chemical stability issue. Safety issue identified. Hybrid distillation scheme, example extractive distillation, may lead build up concentration, certain component, particular area, dividing one column may similar issue, unexpected build up, certain locations. Okay guys, this is somehow with example we are discuss what are hazard in distillation column. I hope you like this topic and my video. Next Sunday we have covered some another chemical engineering topics. Till then, goodbye. Do take good care of yourself.